in this video I want to do two things. First of all, I just want to point out that there's one formula in this section that we're not covering. And so those of you who are being diligent in reading the book, thank you for doing that. But you can feel free to skip over this. You're welcome to read it if you want, but you'll notice there are no homework problems assigned. That's just if you have some copies of sine x plus some copies of cosine x. There's a neat way of writing that so that it's just a single transformation of the sine function. Really cool trick. The reason we're skipping that is because you don't really use that again until differential equations. Those of you who are going to take differential equations are going to find that you'll often get as your solutions something that looks like this, where it's a copy of some sines plus some cosines, and then you're asked to graph it. Well, graphing a transformation of sine or cosine, we know how to do. Graphing a sum of sines and cosines, we don't know how to do so much. Okay, so it's incredibly useful to take something that would be difficult to graph and turn it into something that's much easier to graph. But again, we don't really use that much throughout the first couple semesters of calculus, so those of you who are going on all the way to differential equations will see it there, but then the version that's used in the differential equations book writes it in terms of cosines instead of sines, so it's a slightly different version anyway, so we're just not going to cover that this semester. Okay. I do, however, want to continue practicing to prove some trig identities, and now we're going to be proving some trig identities that involve some sum and difference formulas. So I've chosen an even numbered problem from the book. We're going to work through this one together, and then in the next video I'll have you try one of the homework problems that's assigned. All right, so we want to prove this. So here's my left-hand side, and here's my right-hand side, and it definitely looks like the left-hand side is the more complicated side, so I want to start with that. Okay. So the left-hand side is cosine of x minus y minus cosine of x plus y. Again, I'm just copying it out. This copy is off limits because it's connected with an equal sign that I haven't justified to the right-hand side. Okay, so it looks like here I'm using the difference formula. Okay, so I want to remember with the sum formula, the cosines go together and they're first, and then the sines and we're subtracting. So with the difference formula, we'll be adding instead. So it's cosine x, cosine y, plus sine x, sine y. And then we're subtracting this. Very important that I put that in brackets or parentheses because I'm subtracting the whole thing. But of course, the sum formula is going to give me a sum of two terms. Okay, so that's cosine x, cosine y, minus sine x, sine y. So now I have to distribute that negative. So we'll have cosine x, cosine y, plus sine x, sine y, minus cosine x, cosine y, that's nice, minus a negative is plus sine x, sine y. The cosines cancel. Looks like I've got two copies of sine x, sine y. And that's exactly what my right-hand side was. So we have, in fact, proved that identity. Excellent.